good scientist and I know you're going to be really good at investigating things. I like that. Now, what I'd like you to do is to make a run using 5 of these butters only. Only 5. And what I'd like you to do is find an efficient, a good, a productive way of transporting water through your system. How could we make that fair? Now, everyone's only allowed to use 5 butters. And we're going to be transporting some water down it. How could we make that fair? I'll chat to your partner.
How
could we make it fair? Toby?
Because if you pour like 3 jugs at once, it would make the slide down. So, because that's what happens with mine and Theo.
So the amount of water might make it difficult. So what are we saying? Because each team is going to have 5 butters each. So how could you make it fair for all of the teams, Katie?
Well, if you get a cup,
yeah,
if they have numbers on,
they do have numbers on, don't they?
And then you could put the jug in water until it gets to that.
Oh, what number do you think might be? Now I know that it goes up to a litre. Do you think a litre might be quite a good number?
No.
What do you think?
Maybe half a litre.
I'll tell you what, we can investigate with half a litre afterwards. That can be your challenge. For now, we're going to stick to a litre. Well done, Dan. Alright. Away, 5 butters only. Now you need to save as much water as possible from your litre. Go, go, go.
Yes, water.
Okay,
could we use this? No, that's not. No, let's go. Investigate for. No, 1, 2, 3. No, wait. It's going to splash out.
Let me ask you boys, what was going wrong in yours? What was happening at the top? It was going over the edge. So what does that tell us about the way that we need to do the experiment then?
It needs to be more smoother.
Oh, it needs to be a bit smoother, doesn't it? A bit more gentle. I think I agree. What was happening on yours? What did you discover?
We kept on trying new things and then we found one that actually worked.
So tell me about your investigation that you were doing that was working.
So we put a jug up there and then there was a jug down there.
Why did you put a jug at the bottom?
So we could see if we could catch the whole litre.
Catch the whole litre, and then that's how you measure it, isn't it? So
And it
see
works.
everyone. So that's how, and it works. And Danny, what were you doing in your week? 'Cause actually, these two were really busy and Danny was kind of stood for a little bit like this until he found a job. What job were you doing?
Well, I was doing adjusting it, so similar to what Harry said. When you poured it down, it might flow off the edge, so we extended it a bit to the side,
I see.
so it wouldn't get as much down.
You were looking out for like holes and actually where it was losing, making it less efficient.
Because the good thing about ones like these, you don't have to worry about holes because it's more dropping. But then if you do have holes, it's more efficient.
That might be a good theory. Now Dan actually came up with a really good investigation for next time. Dan said, what about if we make the number of butters less? Would that increase or decrease the efficiency? And after we've done this investigation, Dan, maybe another time during science week, we can have a look and see what you reckon.
Yeah.
Okay, Natalia, what did your group discover?
Well, on our first one, it was like kind of
A bit too much at once.
Yeah.
Okay.
But at the bottom, same as that, we put a cup at the bottom to catch most all the water to see if all the water we put down was in there, and the same water. And then I thought of a different way to make it like a different shape so the water won't push down.
And yours is a very interesting shape, so you're investigating the shape. Alright. Now what I'd like you to do is, we're going to see which design works. So we're going to all start off with 1 litre of water. And I'd like you just to think carefully about how much you're collecting at the edge now. You have some scales at the side. And it should tell you how many millilitres you might have collected of this. with the end result. Has it been very efficient if it started up here?
Mom.
Not very. So you need to have a look at it. We're trying to get it as close to 1 litre as possible. What do you think? We all know how to make it fair, make sure every team member has got a job. Off you go.
Can we try this again? Might need to extend. Now put it through again.
Yeah, we could
That's what it is.
Yeah, look.
It's overlapping over the end. I'll pull. That's better. Guys, I'm just starting from here.
What I'd like to do is I'd like to look at some results. I'd like to compare what we've come up with. So what we're going to do, we're going to watch each team work their rules. Alright? We're going to be taking some final measurements. Do you boys want to go first? Okay, we can see how Harry's tipping it rather slowly. Now to make sure it's as efficient as possible. Now it is dripping, but what do you notice about the drips? Where are they going? They're going to the gutter at the bottom, aren't they? That's a very clever system, boys. Well done. Now, let's measure it. And that is, exactly 1 litre. Can we give them a clap, please? Well done, boys. Okay, it's working very well. Now, as you can see, this group, and it's absolutely fine, don't panic, I've only used 4 gutters. Do you think that that's affecting the efficiency?
Yes.
Oh, so maybe it is, maybe it isn't. Louis doesn't think that it is. I wonder why. Okay,
flowing.
let's have a look. Now, this wouldn't be fair if we're comparing it with the rest, but actually that is a very good system because they've got another litre. Have you definitely got, Katie, have you definitely got 1 litre? You need to check your measurements first. Katie, check it. You don't need to tip it, just check it.
I'll check it here.
Okay. Oh, your partner's okay, now this one's interesting because if we tip it and the water goes down, we can see that over here there's actually an extra gutter. Shelly, do you want to explain what that's for, love?
Well, it's if instead it doesn't all fall out, like if it was real guttering, at least if it doesn't fall out, it falls into the last bit.
I see, so it's something to actually kind of bounce it back off. That's great. Well done. And I love it how it's nice and neat. There's very little look. They went about it in a different way. Now if we have a look at the top, there's a gutter just here. And actually gutters coming off, but it's actually a bit like a triangle shape. Now, tell you can wait over here with that's it, so you can still see it, but so that everyone else can see. How efficient do we think? Let's test it. Now the girls actually put the bit on top. Miley, why'd you put that bit on top?
So that the water will splash out.
So we're struggling with the splashback of it. So they solved that problem by putting a piece of butter in on top. Excellent teamwork and problem solving. If you were to do this investigation again, and you could change some of the variables or different things that you can change in an investigation, if you could change something to do the test again, what would you change and why? Have a chat to your partner, what would you change? Do a different investigation. What sort of things could you change? Manny, what were you talking about, sweetheart?
We would change how many gutters we have.
That might be
There are
really
different
good.
ones that are also curved, so then we'd have to try all the curved bits.
Oh, so actually you could try all of the curved gutters and then the gutters that are a bit more straight. Why not? Fantastic. What would you change? Do you think it has to look? No, it can be bleach. And actually, well, we could do different types of materials, couldn't we actually? We could do different densities and different materials, alright? What a great investigation. I think you worked really hard today. Wonder if you've enjoyed it. I've loved it.